Okay, year 2, AA, I'm gonna go ahead and go over number 9. I'm gonna do number 9 on page 424 on section 9.3. I think this is the question that Ray posted it or emailed me and asked me if I can go over this. He has a question about this. So I'm gonna go ahead and use this video to go over these questions with you guys. So say find the exact values of the coordinate. So every time when you think of the coordinate, it's mean they're looking for the x and the y. They're looking for x and y. Okay. So again, the coordinate of the point x and y on the curve. So this is a curve of the function, the natural log of f. So I'm going to rewrite the function f of x equal the natural log of e to the x plus e to the negative x. Okay, and they want to know what is x and y if I were to plug it into this function. What is my x and what is my y values for this function when the derivative of this function is equal to 0.6. Okay, so in other words, I'm gonna have to go find the derivative of this function. You need to go find the derivative of this function. Okay, find the derivative of this function and take the derivative and set the derivative equal to 0.6, and then from there we can go ahead and find x comma y. So does that kind of clear up what the question is asking you to do and what you have to do? So again, you're gonna go ahead and find the derivative of this function. Okay, and of course the derivative of ln x is 1 over x, but in this case it's not just x, it is e to the x plus e to the negative x. So first things first, I'm going to go ahead and find the derivative of this function, and the derivative of this function is, I hope you guys remember, I think I put the sign in the wrong place. Okay, the derivative of this function is going to be, okay, f prime of x is going to be equal to e to the x plus e to the negative x. Again, you're going to find the derivative of that over, okay, it's 1 over 1 over x, and in this case that is e to the x plus e to the negative x. Okay, hope that makes sense so far. And again, if you don't know what I'm doing here, just follow it, and then trying to go back to the previous chapter and look up the rule how to find the derivative, and chapter 9.3 where you find the derivative of natural log, the natural log function. So from there I'm going to go ahead and find the derivative of e to the x, and again the derivative of e to the x is e to the x, and the derivative of e to the negative x is going to be, remember there's a 1 here, so you're going to take down the negative. That's negative e to the negative x over e to the x plus e to the negative x. Okay, so now I'm going to go ahead and take the derivative. I'm going to go ahead and take the derivative, which is this whole thing, and I'm going to set this derivative equal to, I'm going to take this derivative, I'm going to set it equal to 0.6. Okay, and again to solve for this, I'm going to put a 1 under. I'm going to go ahead and do cross multiply. So e to the x times 1 is just going to be e to the x minus e to the x and negative x times 1 is just going to be e to the negative x equal 0.6 e to the x plus 0.6 e to the negative x. Okay, put a line through this so we can go over here and finish it up. Let's continue over here to the right side. All right, So from there, I'm going to see if I can isolate the variable. I'm going to bring everything to one side to solve for x and set the equation equal to 0 and see what I can do with this. So if I bring the 0.06 e to the x over to the left, so that's going to become a negative. So remember, think of this as a 1 here. Think of this as a 1 here. So 1 minus 0.6 is going to be 0.4 or 0.4 e to the x. And then, so again, that's what I'm going to get when I bring that over. That's become negative. Same thing, I'm going to bring the 0.6 e to the x, e to the negative x over to the left. And that will give me, that's going to be negative 1.6 e to the negative x, and that will be equal to 0. So how would I solve for this problem? Again, this is all about, now it's come down to like algebra. So what can I do to solve for this problem? And one way to do this is, what happens if I take all the terms and I multiply that to e to the x? So if I multiply this to e to the x, I will have 0.4 e to the 2x. Remember, when you multiply, same base, you add the exponent, right? So x plus x is 2x minus, same thing here, if I take e to the x, e to the negative x times e to the x, and that will become e to the 0, because negative x plus x is 0 and e to the 0 is always equal to 1. So all you have left in this problem, in this part right here, is just 1.6, and you're going to set that equal to 0. Okay, everybody good so far? From there, I'm going to go ahead and isolate the equation again. That's going to become 0.4 e to the 2x equal, bring the 1.6 over to the right, that's become a positive 1.6. If I want to get the e to the 2x by itself, I'm going to divide everything by 0.4. So 1.6 divided by 0.4, okay, or 0.4, and that will give me e to the 2x. Okay, 16 divided by 4. 16 divided by 4 is 4. So 1.6 divided by 0.4 is 4. Everybody good so far? Once I get to here, I'm going to go ahead and use my natural log rule or log rule. I'm going to go ahead and take the natural log of both sides. Okay, I'm going to take the natural log of both sides. So let me leave some space here. I'm going to take the natural log of both sides. Natural log of e to the 2x and the natural log of 4. Again, and then I'm going to go ahead and use the power rule, bring down the 2x to the front. So that's going to give me the natural log of e is equal to the natural log of 4, right? Natural log of 4. Everybody good so far? So 2x equal the natural log of e times the natural log of e equal to the natural log of 4. At this point here, you definitely can use a calculator if you want to, or you can think of this as 2x ln e is equal to the natural log of 2 to the second. So I'm just going to rewrite the 4 is the same thing with 2 to the second. Alright, I'm going to come up here. I'm going to finish up the problem. And again, this problem might take you 15-20 minutes to do them all out. Okay, so from there I'm going to go ahead and you take down the 2. So I'm going to have the 2x, okay, ln e, the natural log of e is equal to, bring down the 2, so I have 2 ln 2, 2 ln 2. So obviously in this case, so it's, well, what is by the way, what is the natural log of e? Well, the natural log of e is just 1, right? This is just 1. E to the what power give you e? Again, so that's going to be just going to be 2x is equal to 2 natural log of 2, 2 natural log of 2, okay, or 2 or a natural log of 4 of 2 to the second. So now if I want to get the x by itself, I'm going to go ahead and take x equal the 2 natural log of 2, and I'm going to go ahead and divide that by 2. And I can go ahead and reduce the 2 to the 2, reduce the 2 and the 2, so x is equal to the natural log of 2. So if you want to know the exact values of what is the natural log of 2, again you can punch this into a calculator. So what does it mean is this, at the derivative at 0.6, okay, on this function, on ln e to the x plus e to the negative x, the x values is natural log of 2. So how do you find the y? Well, now if I want to find the y, I'm going to go ahead and substitute the natural log of 2 into the x to find the f of x, which is the y with the y values. So again, down here, I'm going to go ahead and find f at natural log of 2. Again, replace the x by the natural log of 2 equal the ln of e to the natural log of 2 plus e to the negative natural log of 2. Okay? Did I lose anybody in here so far? And come to here, I hope you guys remember that the e to the L natural log of 2 power, that is the same thing with, that is equal to 2. Plus, well, you can always rewrite the negative exponent by bringing it down, so you can put 1 over e to the natural log of 2. So that is the same, but again, e to the natural log of 2 is equal to 2. But since the negative, so you're going to take the reciprocal, so that's going to become negative, that's going to become 1 over 2. And that will give me ln, well, 2 plus 1/2 is a 2.5. And 2.5 is the same thing with 5 over 2. So that right there is the y values. This is my y. Okay, so therefore, ladies and gentlemen, I can go back here. I can go ahead and say my x value is going to be the natural log of 2. And the y value is going to be the natural log of 5 over 2. And that right there is going to be my x and y coordinates. Okay? Any questions? Let me know. Look over the video and we'll do another practice problems on this, because I'm pretty sure you're going to see something like this on the IB exam.